population to quadruple will be 9.97 years. Hello guys, I hope you're doing great. In this video, I'll be explaining to you a particular application of first order linear differential equations. The first most common application is when you have a quantity, the rate of change in that quantity is directly proportional to the value of that quantity at a particular instant. Instead of explaining the theory in this part, because we have already looked at all the theory in the previous videos, we can directly go and solve the problems. So I'm going to show you the solution to problem 1, which is from exercise number 3.1 of Zill and Cullen book, 7th edition. So the problem states that the population of a community is known to increase at a rate proportional to the number of people present at time t. So how do we go about translating this sentence into mathematics? So first of all, we know that there is something called a population, right? So what we can do is we can say that we are representing population with capital P, and this population is changing with respect to time. So we say that time can be denoted with t. So now what we are saying is that population is a function of time, and it is directly proportional to the rate of change of population at that time. So this is how we translate this sentence or this problem into a differential equation. So this is not a proper differential equation yet. So what do we need to do? We need to take away the proportionality sign and introduce a constant of proportionality. So dp of t by dt, I'm flipping the left hand side and the right hand side, equals k times p of t, where k is the constant of proportionality. And to solve these problems, we are normally given with more information. So the further information that is given, it is that if an initial population p0 has doubled in 5 years, how long will it take to triple and to quadruple? It is an initial value problem, and initial values are used for real life applications. Initial value or initial population is called p0. So we are using p0. This p0 could be any value. It could be a number of people like 1000, 2000. It could also be constant like p0. So the information that we are given with is that the initial population p0 has doubled in 5 years. So when time goes from 0 to 5, the population p of t goes from p0 to 2p0, right? So this is how we can translate that statement into maths. So now the big question is, how do we use this information to solve this differential equation? The answer to that is that we don't do that right away. First we solve the differential equation for its general solution. So I'm going to solve this differential equation for its general solution, and then I'm going to use the initial values into that solution. For the sake of brevity, I'm going to use simple p instead of p of t. Okay, so I'm going to use the equation dp by dt equals k times p. So now I'm going to rearrange this equation just like I'm taking everything in p on the left hand side and everything as a constant or a function of time or anything like that on the right hand side. Then I'm going to take the integral on both sides. So when I take integral on both sides, the left hand side integral is natural log of p and the right hand side will be k t, and there will be a constant of integration. So this is a standard solution that we have already done a couple of times in previous videos. So how do we get rid of this natural log? Because we would like to have a solution in terms of p only, we make all of this equation a function of exponent e. So on the left hand side we get e to the power natural log of p equal to, the right hand side is e to the power kt plus c, and we can further write it down as, it's a property of log that we can interchange e and p. So we can write it down p to the power natural log of e equal to e to the power kt, and we can separate this exponent based on the power. So the natural log of e is 1. So on the left hand side we get p, and on the right hand side we get e to the power c. We also name this as, let's say, capital C. So On the right hand side we get capital C e to the power kt, right? So this is the equation, and you must have noticed that in this equation we have two unknowns. First unknown is C and the second unknown is K, and we are given with some information which we had written over here. So let's use this information to find out the values of C and K. So we know that at time 0 the population was P0, and at time 5 or 5 years the population became twice that of the initial population P0. So whereas the function of or the solution of P of t we have just found out to be C e to the power kt, right? So let's translate all of this equation for time t equal to 0. What do we get? We get P at time 0 equal to C e to the power k multiplied by 0. So we, on the left hand side I can change P of 0 as P0 because we have already named or given with a value of P at time equal to 0 as P0, and on the right hand side we get C. So we can say that we have got the value of the constant of integration, which is P0. This is first finding. So as I said earlier, if P0 was given to be as a number or 1000 or 2000 or anything like that, it would be different, but it's okay to use any named constant as well. So now we need to find the value of k, and to find the value of k, we what are we going to do? We're going to use the second information. We're going to use the second information that at time t equal to 5 the population doubles. So let's write down the same general solution at time equal to 5. So we get P of 5 equal to C e to the power k into 5, because now we are looking at this equation at t equal to 5. Now after 5 years the population doubled. So now here I'm going to write 2P0. I have already written it over here. At 5 years the population doubles, right? So on the right hand side we have already found the value of C, which is P0. So I'm going to write down that thing, and here we have e to the power 5k. P0 obviously cancels out and we're left with e to the power 5k equal to 2, and now we have to find the value of k from this. So I'm going to take natural log on both sides, so I can write it down natural log of e to the power 5k equal to natural log of 2. So the left hand side becomes 5k into natural log of e, because anything in the power can be brought outside of the log. That is a property of log. And on the right hand side I get natural log of 2. So the value of k becomes natural log of 2 divided by 5 natural log of, and by the way natural log of e is 1. So all of this will be 1. So we don't need to write that. So the answer to this will be 0.139. So now we can use this value of k into the general solution, and we got a particular solution, and that will be that P of t equals, now the value of C was, we found it for as P0. So P0 and e to the power kt. So k we just found out to be 0.139, and here it will be t. So now let's go to their question. That their question was, how long will it take for this population to triple, right? So we want to find the value of t when P0 will become 3P0. So on the left hand side I'm going to write down 3P0 because we are interested in a population which is 3 times the initial population, right? And on the right hand side I'm not going to change anything because we don't have any more information about this scenario. P0 cancels out, and just like in the previous steps, we will have e to the power 0.139t equal to 3, and we're going to take the natural log on both sides, and we get the value of t will be natural log of 3 divided by 0.139. So the answer to this becomes 7.9. So the population will triple after almost 8 years, whereas the population doubled after 5 years, right? So the last part of this problem is how long will it take to quadruple. So we are going to repeat all of this for the value of 4p0. So instead of 3 we're going to write 4 now, and instead of 3 here it is also going to be 4, here it is also going to be 4, and the answer for the population to quadruple will be 9.97 years. So the population doubles after approximately 8 years, and the population quadruples after almost 10 years. So I hope you understood how we use first order linear differential equations in real life problems. I leave you with the problem, so please try to do this problem, that the population of bacteria in a culture grows at a rate proportional to the number of bacteria present at time t. This is problem 4. So you can easily see that this is exactly the same problem of population that we earlier did. After that, it says that after 3 hours it is observed that 400 bacteria are present, and after 10 hours 2000 bacteria are present. What was the initial number of bacteria? So this is just a flipped problem of this problem, and in which you are supposed to find p0 instead of a given p0. So please try to attempt this problem and write down the answers in the comments below, and subscribe for staying in touch, and we'll see you in next video.